Hey everyone, I'm Trent, and in today's video, I wanted to go through a topic that I think is often overlooked by Python developers, and that's debugging. So I think we've all had pieces of code where we've used print statements all over the code to try and figure out what's going on under the hood during execution. But I want to go through how to do this in a more effective and more efficient fashion. So in a recent interview, Lex Friedman, who is interviewing Guido van Rossum, the creator of Python, asked, "Where is most of the time spent in programming?" And Guido van Rossum answered that 75% of programming is debugging. So you can kind of see why it's really valuable to be as efficient as possible when you're debugging your code. So how I'm going to do this is I'm going to show you two different ways to debug your code. One way is going to use the command line. Nothing fancy. You're just going to use base Python to debug the code. And the other way is going to use an IDE. I use VS Code, but the concept can be applied to almost any modern IDE. All right, so to kick things off, I want to explain the code that we're going to be debugging. Okay, so over here we have a script that I've called Simple Prime Finder, and what it does is it finds prime numbers that are up to but excluding this input num variable over here. So in this case, I've entered the number 10, and so what this code should do is look at all or find all the prime numbers up to but excluding 10. So how it does that is in this main function, it'll go and call this find primes function. And in find primes, it iterates through all of the numbers up to, but excluding the number given, and tests if it is prime. If it is prime, or if the statement is true, it will print out the prime number. So to figure out if something's prime, we've got yet another function. And what is prime does, it is iterate through all the numbers prior to num, so everything before num, and then tests if it is divisible or modular divisible by that number. So if you're unfamiliar with modular division, it's basically just a way that checks for a remainder between two numbers being divided. So for example, 10 mod 4 would give you 2. That's because the remainder is 2. So 4 goes into 10 twice, right? That's 8, but there's 2 as a remainder. So that's how modular division works, and that's denoted over here by this percentage sign. So if the mod is 0, that means that the number is perfectly divisible. So by this index over here. So if you say, for example, num is 10 and index is 5, their mod is going to be 0. That's because 10 is integer divisible by 5. And therefore, it's not a prime number. Because if you remember, prime numbers are numbers which are only divisible by themselves or the number 1. Right? They're not divisible by any other number. So if they're divisible by any other number, we want to return false. Otherwise, we want to return true. So that's just the basics of the code. It's not too important to understand everything that's going on, although, I think it's kind of valuable. What we really want to do is test out if this really simple program works. Cool, so let's try it out. Let's just run it. Let's open up our terminal. And for this tutorial, just so that we are on the same page, the version of Python I'm using is Python 3.8.8. Just to prove that, if I type in Python -- version, you'll see it's Python 3.8.8. So if you're following along, I recommend using a version, this version, or a version that's higher than this. Alrighty, so to run this, assuming that you've got Python installed, we don't need any other extra packages to run this code. This is just in base Python. So to run this, we'll type in Python and simple prime number or prime finder. And if we hit enter, we see we've got an error. So it looks like we're getting a zero division error over here, interdivision or modulo by 0. All right, that's not great. So we know that we've got a bug in our code. Now, looking at this output, it's pretty easy to see where the bug is. It's happening at this line over here. It even tells us on the output over here, if I control and click on that, it'll take us to the line that's causing the error. But let's investigate this a little more thoroughly. And how we're going to do that is by using a debugger. And specifically, we're going to be using the Python debugger. Now, like I said, I'm going to do this in two different ways. First, I'm going to do this on the command line, which is a little more old school, admittedly. So if you want to skip ahead and see how to do this with an IDE, which is the kind of more modern approach, feel free to skip ahead. Cool. If you didn't skip, I respect the commitment. Awesome. So let's add our debugger. So to do that, in our script, we're just going to import PDB, and that stands for Python Debugger. So again, you don't need to install anything. This ships with Python. This is part of Python. It's one of the base modules in Python, so no need to install anything. And in order to use this, or in order for us to start debugging our code, we're going to need to set a breakpoint. Now, a breakpoint is simply a position in our code or a line in our code where we want to pause execution. So we want to stop execution and save the state of what has happened before that point. This is so that we can see what happened just before we hit that line. And further, we can actually go through each line and figure out what's going on. So I'll show you exactly how to do that if that's a little confusing. So to set our first breakpoint, let's pick, somewhere early on in our code. To do that, we just need to type in pdb.setTrace. So when we run our code, execution is going to pause at this point, open up a little console for us, and we'll be able to investigate and probe our code. So let me show you that. So we've now set our trace. If I run once again at the bottom over here, Python and our script name, if I hit enter, you can see we've got this PDB thing. So make that a bit more clear. Over here, it's got the script that we're running, the path, the full path to the script that we're running. And then over here, there's a little arrow that points to the line that's about to run. So this is what is just about to run. It hasn't run yet, but this is what is about to run if we tell our debugger to proceed. Now, one of the basic commands in the Python debugger is to just list the position of where we are in our code, and that is done by typing L. So this will appear next to this PDB for Python debugger in brackets over here. This is our little debugger console. And if we type in L and hit enter, it'll print out the code itself. So that we recognize this. This is the code from our script over here, right? So it's printed out our code, and this little arrow indicates where execution is paused. So execution is paused at the find primes function, just after our breakpoint. Great, so to actually run this line, I will use the command n. If I type in n, it'll run that line and continue execution. If there were more lines underneath this, so right now this is actually the last line in our main function, so it's not going to run anything afterwards. But if there was another line underneath, next would load up the next line to be run by the debugger. So let's see what happens if we just hit n. Okay, we hit our zero division error again, which is not great. So that didn't tell us much. So let's retry the debugger. To exit the debugger, I'm just going to use Q as the command, Q for quit. Enter that, and let's try again. All right, we've hit find primes again. If I type in L to list our code, once again, we're at find primes. Now, what we really want to do is step into this function. We want to see what's going on in here. It's not really valuable for us to just run that line, get the error again, and have no idea what happened. So let's type in step, and what's going to happen is this will step into the find primes function. So if I hit in step, we can see that the next line to be run is this def find primes, or the definition of our function, and that's exactly what we want. And if I hit n to run the next line, it'll run this def line and hit the next line to be run. So over here, it's the for potential prime in range num. Now, as part of the execution, we can inspect the variables that are available to us. So if I hit L again, just to print out the code, we can see that the variable available to us is num. So right now, num is the only thing that exists in the scope. I can prove that by using the Python dir command, so dir, open bracket, close bracket. That tells us the variables that are available in our scope, or more generally, the objects that are available in our scope. So I can see, okay, we've got num. If I type in num, it tells me num has the value of 10. Great. So that is all as we expect. Now let's iterate through the loop. Let's hit N, and if I type dir again to see what variables are available to us, we can see we've got num and potential prime. So let's type in potential prime over here to print out its value. We can see potential prime is 0. That makes sense because we're iterating from 0 up to and excluding num using the range keyword over here, or the range function. Great. So we took note of what the values are. So let's hit N again. And now it's run if is prime for us already. Has come up to print and prints out 0. So that's a little weird. We don't expect 0 to pop up because 0 isn't a prime number. So that's a bit strange. We'll get back to debugging that. We still haven't hit our 0 division error, so we've already picked up 2 bugs now. So we'll come back and deal with that. Let's hit N again. And now I actually want to step into is prime over here. So if I just show my code, I want to step into this function over here to see what's going on. I'm still not hitting that 0 division error. Let's inspect what's going on in there. So I type in the word step, and there we go. If I hit L over here, we can see it's starting at def is prime. That aligns with the code up here. And if I hit N again to run the next line, we can see we hit index for index in range num. So this is iterating through all of those numbers, or the iterator is going to start to run through all those numbers. So if I hit N again, let's take a look at what variables are available to us with dir, index and num. So let's take a look. What is index? Index is 0 and num is 1. Okay, so now we can start to see what the problem is. Well, it was a little obvious from before, or somewhat obvious, but now we can see it explicitly. If I hit L again, just to show you what line we're on if num mod index equals 0. So effectively we're saying if num modular division with index is 0, then return false, otherwise return true. But we can see the problem. We printed out the values, index is 0, num is 1. If index is 0, we're effectively trying to divide by 0. And so if I hit next, there we have it. We found our 0 division error. So we found the line that's illegal, and we know that it's actually not on the first iteration, because remember, we got 0 back for some reason. It's on the second iteration that's a problem. So we take note of this. Let's exit the debug session by using Q for quit. And to fix this, let's think about how to avoid that problem. Well, we don't actually want to test for dividing by 0. That's not really a condition for a prime. It's also impossible to do, so that is also a deterrent. But to fix this code, we could say let's iterate from 1 onward. But then again, we said the definition of a prime is that it is any number that is only ever divisible or integer divisible by 1 and itself. So this is incorrect, right? If I have 1 as part of my divisor, 1 as index, this is going to tell us that every single number isn't a prime because every single number is divisible by 1. So what we really want is to add a 2 in there. So to iterate from 2 onwards, that's the only time or the only point at which we're interested in checking if a number is divisible by this index. Great. So we've added that in. This should take care of our 0 division problem. Now I've found where the problem is, and I don't want to go and step through the code all over again. I had to step into this function, then further step into this function and hit N a whole bunch of times. I don't want to have to do that. So a shortcut for that, or a shorter way of dealing with that, is let's just set another breakpoint in our code. So to do that, let us go to this line, line 12, and hit pdb dot set trace. So now we've got 2 breakpoints in our code. Great. Now a shortcut that we're going to use is we're going to hit this breakpoint, but then we're going to say to the debugger, continue execution until the next breakpoint. I'll show you exactly how to do that. So let's run our script again. All right, we hit our first breakpoint, but we're comfortable with everything between this breakpoint and this breakpoint. So to hit the next breakpoint or to continue execution to the next breakpoint, we can either type in the word continue, or for shorthand, we can use the command C. So if I type in C, we can see that it has reached this for loop. So just to prove it, if I hit L to list out the code or a few lines of the code, we can see that the execution has paused at our second breakpoint. We didn't have to type in step or N a whole bunch of times. Great. All right, so let us look at what is num this time. Num is 0 once more. Let us run this next line. Okay, that's interesting. So if we hit N and on this, it didn't run our loop at all. And it simply just went to return true immediately. Now the problem is that num is 0 over here. So in this loop over here, we're saying for index in the range from 2 towards num, and if we substitute num for 0, we're saying, iterate in the range from 2 until 0 in increments of 1. That's what the range command does by default, or the range keyword does by default. So that doesn't make any sense. So what Python does is kind of just skips over that. It's kind of like, well, that doesn't make any sense. I can't loop over that. Range from 2 to 0 in increments of 1 makes no sense. I'm just going to skip all of that and return true. So that's why that's happening. And we figured out what our second bug is, or that bug that we picked up earlier now, which is why is 0 being printed out. So we can see now it's returned true. If we hit N and run that, let it return to our calling function. So that's find primes over here. If I hit L on the command line, you can see it's about to run print. So it said if is prime, this returned true. So if true, print potential prime. If I hit next, there you have it. It prints 0. So a little annoying that's happening, but we can figure that out. Let's try and hit the breakpoint again by using C for continue. And let's take a look at what num is. So num is 1, and now this is going to suffer the same issue that 0 had, right? Because for index in range 2 to 1 in increments of 1 also doesn't make any sense. So this is probably going to hit true again. So if I hit N, there you go, it hits true. And if I hit next, we land on this print statement again. So it's tested if is prime, it said it returned true. So let's print out the number, and there you go. 1 is printed out as a prime number, and that's not technically true, right? 1 isn't a prime number. Okay, so we've found the problem. It's this num, this upper bound, and this upper bound comes from the argument we passed to is prime. And if we loop back to this find primes function over here, it gives the num to is prime. So what we want to do is once again iterate from 2 onward, right? We're not too worried about the 0 and 1. Those aren't prime numbers. We don't worry about that case. We know for sure that those aren't prime numbers. So we're just going to iterate from 2 onward. So let's quit and try again. And once again, let's continue to our second breakpoint. So if I hit L, yes, we're at that second breakpoint. If I type in num, this should be 2. So we've skipped 0 and 1. This should be 2. Now, again, for index in range 2 to 2 doesn't make much sense, but it's going to skip over and return true. We're okay with that case because 2 happens to be a prime number, so we're safe. If we hit N, this should return true. There you go, returns true. And if I just keep hitting next until I get to this print potential prime, it's going to print 2. Okay, great. Let's keep iterating. So I'm going to hit continue to hit our breakpoint again. The second breakpoint on line 12. So if I hit continue, there we go. let's type in num. Okay, num is 3 this time. And num being 3, well, 3 is a prime number. So we expect this to return true. So we're going to iterate for index in range 2 to 3. So we're only going to iterate once because there is only one number between 2 and 3, right? So excluding 3. So let's step through that. So let's say n. Okay, so we know that num is 3, index is 2. 3 mod 2 is 1, so that's non-zero. Great. Okay, so it's going to test our for loop condition again. If we hit next, it returns true. There's nothing left to iterate. It's going to return true, and print 3 out. Great, so we got that prime number, and just for sanity checking, let's go one more time. Let's continue to our breakpoint, and let's see what num is. Num is 4. Okay, if I hit n on that, let's print out num and index. So if we think about that, 4 mod 2 is 0, and that's because 4 is divisible by 2. 2 goes into 4 twice. So this should return false. So I hit next, there we go, return false to our caller, and it's going to skip over it. It's just going to jump back to this loop to continue looking for primes. It's dealt with 4, it's now going to move on to 5, and so on and so on. Great. So we dealt with our issues. Let's quit the debugger. Now to run our code, this is a bit of effort. We need to go and either comment out or delete our trace functions, right? Because now we just want to run our script as usual, and just to see if it works. So let's just run python simple prime finder.py, run that, and we see it prints out the prime numbers up to but excluding 10. Great. So this looks like it's working, but we're stuck with this commented out code. That's not great. Yeah, and we've still got this import PDB thing going on over here. So this adds overhead to our script because we're importing a whole module, and when we push this code to wherever it needs to be, when it's running, just doing its thing right out in the wild, we don't really want it to have debug statements in it. Those could cause problems. We also don't want to import PDB. That adds overhead. So if we're putting this on a server somewhere, this is adding overhead to the server, which is just unnecessary. Before I move on, I actually wanted to just discuss one point around using PDB. We actually don't need to import PDB in the kind of like more modern Python, and that's because in the more recent versions of Python, after the Python extension proposal, I forget which number it is, but there's actually a keyword called breakpoint. You don't need to import anything. You can just type out the word breakpoint, open close brackets over here to call it. And this works exactly the same as pdb.setTrace. So it's a little more convenient. I'll just prove to you that it works as we expect. Actually, let's put a breakpoint where we had pdb.setTrace before. Yeah, this is just more of a note than anything else. So there we go. It enters the console as we expect. We can use the same commands to continue, N for next, L for list. It's effectively the same thing. There's just a more convenient keyword now, so we don't have to import PDB. But we're still stuck with our breakpoint lines now. And if we wanted to push this code to a code repo, or like I said, put it on a server somewhere, we have to go and manually delete all of our breakpoints, which kind of sucks, right? That's not convenient. And much like using print statements to debug, you have to go and like search through your code for the print statements and then go and delete them before you move this into a repo or put it into production. So there's a better way of doing this, or let's say a different way. We can still use the command line though, and this is to use PDB on the command line itself. So we're not going to import anything. So let's just remove this just to prove that we're not importing anything. What we're going to do is run PDB on top of our script as a whole. So how to do that is by typing in Python -m. -m lets us run a module. So we're saying Python run a module. That module is PDB, or the Python debugger, and run it on top of simple prime finder.py. And if I run that, we once again enter in the debug console. So if I just expand that, and if I hit L, we can see that it's starting at def find primes. This is the first line to run, but what it's doing is setting up our functions. It's not actually running our functions. Execution is setting up our functions. So if I hit LL, you can see that this prints out our entire script. So LL is for long list. This prints out our entire script. What it's going to do is just register our functions in the stack. So it's not actually using them. Just to show you, if I hit N, you see it's skipped. It's skipped to is prime. It didn't run anything in here. It's just registering the functions. So that's kind of interesting. It's showing you how the execution flow goes. Using the debugger, you're studying how the execution flow works in the code, which is really useful. You don't get that with print statements, right? If I hit N again, we hit def main, so it's registering the main function, and then it's going to run this if name equals main, then run main. It's just going to run this piece over here. Okay, so now we're in the debug console, and we can go through the execution flow point by point by point just by hitting N over and over and over again. But we don't have any breakpoints set, right? We didn't set any in our script, and we haven't set any on the console. So if I hit continue, and just keep continuing, it's going to keep printing out. So I hit it twice. It's going to keep printing out the results 2, 3, 5, 7. So all the primes up to but excluding 10. Then it tells us the program has finished and will be restarted. So we're just stuck in this loop of our program running, completing, and then Python PyDB or Python debugger restarting the execution again. So the only way to exit is to quit. Looping through the execution of our program is only somewhat useful. We want to be able to set breakpoints. So I'm going to restart the debugger console again using that same command, python-mpdb, and our script name. Hit run. And to set a breakpoint, we use the following syntax. We can type in break and then enter in the line number where we want to insert the breakpoint. So previously, we had our breakpoint statement over here on line 21. But when setting the breakpoints over here or in the command line, we want to give the exact line where we want to pause execution. So you'll see if I enter in 21, which is where our actual breakpoint statement was, if I enter in 21, it's going to say this line is blank or is a comment. We really want to enter in line 22 where find primes is. So if we say break 22, you can see the statement returned to us, or the return from that, is that breakpoint 1 at, it gives us the exact script location, and at the end, colon, and the line number. So we set that breakpoint. And if we scroll up, our other breakpoint, we set the statement on line 10, and then execution was paused on line 11. So what we really want to do is create a breakpoint at line 11. So I've set up two breakpoints, and to list them, I can type in break again, and it will give me some details about the breakpoints. So it'll give me an identifier for each breakpoint, their number, 1 and 2, their type, the display, enabled, they're both enabled, where they're at. Okay, and this works the same way as our breakpoints before, but you'll notice that nothing has been added to our code. It's only in this console that these breakpoints exist. So if I hit continue, it'll hit our find primes breakpoint that we've set up. Sorry, I was instinctively pointing at the code, but yeah, the breakpoints only exist in the console. So we actually have to take note of these, visibly saying, okay, that's on line 22. In here, I can hit L, and see, all right, there we go. This little B with an arrow points out this is where the breakpoint is, this is where execution is. So the B represents breakpoint. This arrow says, all right, execution's at find primes. And we can use our usual commands, once again, step, n, etc. If I hit continue, it'll hit our second breakpoint. And yeah, that's pretty much how we do it on the command line. One useful part of using the command line, so if I just list out the breakpoints again, is I can see how many times the breakpoints have been hit. So it's saying that this first breakpoint has been hit 1 time, this breakpoint has been hit 1 time. If I hit continue again, and I hit break, we can see that this updated and said, all right, the second breakpoint has been hit twice. Another useful thing is, if I'm busy debugging my code and I don't want to hit every breakpoint, let's say we want to disable breakpoint 1, I can use the command disable and use the breakpoint ID 1, and it will say that it has disabled breakpoint 1 at that point. So if I list my breakpoints again, you can see its state is enabled is no for that guy. So it will skip over that breakpoint. Actually, it's probably more useful if I disable 2. So now both my breakpoints are disabled. And if I hit continue, it's just going to run the program. It's not going to pause on the breakpoints. They're both disabled. And then to enable them again, just enable 1. And it will enable the breakpoint and enable 2. Enable breakpoint 2. If I hit C for continue, it will hit my breakpoints again. Great. So this is pretty useful, but still a bit inconvenient, right? We have to use the command line. We have to type everything all the time. If we want to see the state of variables, we have to type out their names and print out their values. That's not super convenient. Okay, but this is useful if for some reason you can't use an IDE, or you're not allowed to install certain extensions, or something that helps you out in your development life cycle. You might get a client or somebody who's like, oh, well, I don't trust this IDE, or I don't trust these IDEs. You have to use the command line. That's super, super unlikely and really unviable. But if you're stranded on a desert somewhere and all you have is a command line, this is for you, right? This helps you out. You can go and debug your Python code with nothing but Python itself, which is kind of cool. But yeah, as I said, kind of inconvenient. What we're going to do is move on to the more modern way to debug. Okay, let's quit the Python debugger. Over here on the command line, let's clear. Okay, to start using our IDE to actually debug. So I'm using VS Code once again. The concepts that I'm going to discuss here probably extend to most modern IDEs. So if you're using PyCharm, it might be a little different to set up, but the way that it works is probably quite similar. But yeah, let's move on. Let's use VS Code for this. To make your life a little easier, if you are using VS Code, I'd recommend installing the Python extension. So if you click on that extensions tab and hit Python, or type in Python in the search bar, you'll get this recommended extension over here. This is the Python extension created by Microsoft, and it's verified on the extension store. So I'd recommend installing this. It's actually giving me an alert that I need to reload it for an update, but we'll do that later. It just makes life a little easier when you're dealing with Python in VS Code. Great. All right, to start using the debugger in VS Code, it's really simple to set up our breakpoints. Right? We can go into this section next to our line numbers, and to set up our breakpoints, same as before, we just have to click, and it will highlight a little red dot over here, and that indicates a breakpoint. So nowhere are we typing into our code set breakpoint or using the breakpoint keyword. We are simply adding a breakpoint from the IDE's perspective. It doesn't affect our code in any way. So if we wanted to push this to a repository, these breakpoints wouldn't stick around. All right, so let's put one breakpoint on find primes. Let's put another breakpoint on the for loop in isPrime. And to run the debugger, we will select this run and debug option on the slicer on the side, or this kind of a blade menu on the side. And to start the debugger, all we have to do is click run and debug. It'll open up a console here to ask, what are we debugging? This is just a basic Python file, so we'll select that. Okay, we'll do some stuff. It opens up a new console for us, a debug console. And there we go. It has hit the first breakpoint. It has highlighted the line for us in yellow, and we can see that execution is paused. So we've also got this little menu up here that lets us control the flow of the debugger. So I'm just going to move this over. I can move this over here. And on the side, we've got a whole variable section. This tells us what variables are available to us while we're debugging. And this is super convenient, right? If we were using the command line, we'd have to print these out. So this is great because we can already see the variable input num has been set to 10. Awesome. So to step into this function, because I want to inspect, let's say, find primes, you would click on this down arrow over here and it tells us that step into. There's also the keyboard shortcut F11 for that. But if I click on that, we can see this highlighted yellow line, which represents what is about to be executed. The line about to be executed has paused over here. And we can see that the variables in locals, so our scope has changed. We're now inside this function, and the num is 10, or yeah, num is 10 over here. We no longer have input num. That's part of the scope of main. This is now the scope of find primes. Great, so to start our iterations, we can just say step over or use F10. So we can click step over. And we can see that the first iteration of the loop has started. We've got potential prime starting at 2 over here. And yeah, we've just started the first iteration. So we're going to test this if condition over here. But to step into is prime, if we wanted to inspect that, we can click step into again, and it takes us to the next line to be executed, which is this loop. Once again, our locals have updated, our local variables have updated. Now num is 2 in this scope. If I run over that, we can see that 2 has been determined to be a prime number. That's just one of our edge cases once more, right? Index in range 2 to 2. That is that can't be evaluated in the loop, right? Range can't run from 2 to 2 in increments of 1. Yeah, so it just kind of returns true over here. If I step over that, it's going to print out 2. So we're back in our find primes, and you can see we've got a couple more things in locals now. It's saying the return of is prime is true. So yeah, we've got the state of is prime, it's true, and that's why we're at this print statement. So let's iterate over that. And we can see in our console at the bottom here, we get the printout of 2 as our first prime. So I can continue with this. If I want to hit this breakpoint and not have to cycle through, click and step through or hit, I believe it is F10, right? Hit F10 over and over again. I can use this continue or F5 while I'm using the VSCode debugger to run until I hit my next breakpoint. So if I click on that, it'll run until I hit the next breakpoint. We can see that num is now 3. So let's hit continue again. It'll run all the way through until we hit the next breakpoint, which happens to be this breakpoint again because we're going through this loop. And we can see that it's updated once more. So let's run. Num is 4, num is 5, etc. Right, we're looping through and hitting this breakpoint over and over again. So if I hit continue, right, we hit index is 2, num is 5. So we continue evaluating and iterating through our program. Great, so this is super convenient, and we can see the iteration happening in real time. We didn't have to sit and print any of the variables. We don't have to type anything. We can just kind of sit here and click and watch what's going on. Something else that's convenient about the VS Code debugger is down here. We have a debug console, so in case we did want to test something out by typing in some code. So let's say I wanted to check if num, so I've got num available to me in local, so it recognizes num. I want to see, is num modular divisible by, let's say, 3? If I type that in, we can see there's a remainder of 1. So, the integer division is non-zero, meaning that this number, or 7, is not integer divisible by 3. So yeah, we can type in code over here. I mean, we can print, it's just like your usual Python REPL. So we can print hello even if we wanted to. That has nothing to do with our debugging session, but hey, if you wanted to do that, you could. So that's pretty convenient as well. Now, if we wanted to, let's say we found a bug like we did earlier, we were iterating from index in range num instead of range num2. We ran this, we picked up on a bug. We can, in real time, go and update our code and continue the execution. It'll recognize our updated code. It won't use the kind of old version of the code. So that's really useful if you're dealing with a bigger code base. That's really convenient to test out your edits, in real time. If we really wanted to restart the debugger, we don't have to, quit and exit out of it. We can just hit restart, this kind of green arrow over here, and it'll restart the debugger from fresh, and restart execution, so we can continue testing and not have to, exit and rerun, which makes it really convenient. Let's delete that. Now, if we want to exit the debugger completely, we can use the stop or Shift F5. So if I hit that, we exit out of the debug or the debugger on VS Code. Great. So that's all good. I think that's a heck of a lot of information, and I think it's already useful to know all of that, and it will help you out just knowing that amount about the VS Code debugger or debuggers in general. But something that's a little more advanced, we can actually edit our breakpoints. So if I click on my breakpoint, right click on my breakpoint, I can edit it and set an expression to say break when this expression evaluates to true. So I can say only break when index is equal to, let's say, 7. So I only ever want this breakpoint to pause execution when index equals 7. So if I do that, hit enter, and I run and debug again, I'm probably going to hit this guy first. Yep. And if I go and continue until the next breakpoint, there we go. We hit a zero division error. That's a little strange. What did I? Oh, I didn't update this. I reintroduced this bug. um, so, whoops, shouldn't have done that. This should be 2. Let's retry that. But well, let's retry that before we take a look at if the breakpoint was correct. Great. Continue. Okay. It exited because index never hit 7, apparently. So let's try something a little better. Let's cancel that. Let's right click. Let's say, let's use something like index equals 5. So we only ever want this breakpoint to pause execution when index is 5. So if we hit enter on that, let's rerun our debugger. Okay, it's going to hit this breakpoint first. Let's hit continue. And there we go. You can see that it's only paused when index equals 5, and num is 7. But more relevant is that our breakpoint was set to only break or pause execution when index equals 5. So that's pretty useful as well. If you don't want to go through the entire loop or anything like that, you can set expressions on your breakpoints. Nice. So that's something that's really useful on VS Code and really convenient to do. If I right click, there's some other options over here. So if I edit breakpoint, let's delete that. You can see that there's other options over here. You can set the hit count. So we saw that actually when we were using the command line debugger, but you can say once this has been hit X number of times, then break or pause execution. And then you can also set a log message. So when this breakpoint is hit, print out a message, basically, which is also kind of useful. Okay, let us just exit this. If I just hit enter, that's fine. One last thing from a more advanced debugger or more advanced debugging on VS Code. You'll see an option here to create a launch.json file. This lets you configure your debuggers. So let's hit create one of these guys. Let's just say it's a normal Python file. It will now create a launch.json file for you with a configuration in it. If you go back to your file explorer, you'll see that a new folder has been created or a new directory called .vscode, and underneath that will be launch.json. If you already had a VS Code directory, it'll just add launch.json to that. So in here, this has got a set of configurations for our debugging session. So for example, we can name our different debugging sessions. We can declare a type. We're just using Python. The type of request, the file that's being run or how to path to that file being run. what console to use and running just your code. So if you wanted to debug a module someone else has written, you could set this to false, set breakpoints in their modules, and see if their module is causing the bug, not your code. Perhaps it's the module that you're using. But a useful configuration that I like to use is actually something called arg or args. And in here, I'm just going to give it a value of 10. And what this lets me do is say, when I'm running the debugger, on the command line, give this argument to my script. So let's say I wanted to make my simple prime finder a bit more dynamic. And actually, I wanted to get this input num from the command line, so someone didn't have to go and edit my code in order to change the number up to which they wanted to find primes. Over here, I can say, let's say from sys import argv. So this just lets us collect command line arguments in our Python script, nothing too serious. So we're going to say input num equals argv, and I think it is index 1 to collect our first command line argument. Okay, so just to show you how this works without running the debugger, let's run our code, Python, simple prime finder, and now I hit space, and my argument I'm going to give to it is, let's say 20. Let's find all the prime numbers up to but excluding 20. Oh, okay, so we got an error over here. String cannot be interpreted as an integer. Okay. So we need to cast this. It's not a string, it should be an int. Let's cast this as an integer using the int keyword. Let's run this. And there we go. We've got all the prime numbers up to and excluding 20. So that's 5, 7, 11, 13, 17, and 19. Great. Now, if I wanted to run my debugger, let's actually remove this for now. I'll re-add it. If I wanted to run my debugger on this, you can see we now have an option for Python current file. That's what we call the debugger. If I ran this, I'd get an error because I haven't given it a command line argument. So let's run that. Okay, and there we go. Index is out of range. That's because there are no arguments for it to accept. So that's pretty inconvenient when I'm using my debugger with a command line application. So to edit that, I go into my launch.json file. I add this arg, so I have that on my clipboard. Args, and let's, for fun, let's just use 10 again, or what heck, let's use 20. Cool. And now if I run the debugger again, so I've modified this configuration in here and said, hey, give it an argument of 20. If I run this, I click run on that, this should work. Great. It is happy again. We can see that input num is 20, so that all worked fine. There's a whole bunch of other stuff you can configure in the VS Code debugger. I'm not going to go through all of it. This video is long enough. But when you set it up, there's this convenient link over here that takes you to the VS Code documentation and shows you all of the customizability of the debugger. It is really, really powerful. So yeah, if you're doing something a bit more complicated and really need to customize your debugger or have multiple configurations, I'd strongly advise checking that out. Great. So in this video, we went through the different techniques to debug our Python files. So we went through how to do this on the command line and how to do this in our IDE, or specifically in VS Code. I hope that you found this valuable and can see why debugging is so powerful. Of course, we only went through a really simple script, but it really yields value when you're dealing with a project that is much larger. Having print statements everywhere in a large project is going to cost you a lot of overhead. You need to rerun this entire project over and over again to see your print statements, and then remember to go and clear them later on. This really, really pays off dividends when you're dealing with a sizable project. If you've made it this far in the video, I really appreciate you watching. And yeah, to support the channel, why don't you go and check out another one of my videos? Yeah, so thank you so much, and I'll see you later.